Imagine a future where humanity isn't stuck on just one planet. Not some desperate escape, but a bold new adventure, a whole new chapter in our cosmic story. For centuries, we've gazed at the stars and wondered, could we call anywhere else home? Well, that question isn't just for sci-fi anymore. Right now, as you're listening, scientists are pinpointing real worlds that could, just maybe, become humanity's next address. Forget those wild dreams of far-off, impossible galaxies. Some of these contenders are practically in our cosmic backyard. Others are a bit further out, but flash some seriously tempting possibilities. Today, we're pulling back the curtain on the top 5 celestial bodies that show the most promise for human life. We're talking about places where, with enough smarts and a good dose of courage, humans couldn't just visit, but could actually set up camp and, survive. 2 of these are probably familiar names from our own solar system, kind of like our cosmic siblings. The other 3 are distant exoplanets, orbiting stars way beyond our sun, each with its own unique features that landed it on this incredible list. So, get ready for a new perspective as we unveil these amazing worlds. Kicking off our list at number 5 is a super-Earth called HD 20794d. It's about 19.7 light-years away, which sounds far, but in cosmic terms, it's not too bad. This exoplanet orbits a G-type star. That's the same kind as our own sun. This is a pretty big deal because a sun-like star means a certain familiarity in the kind of light and energy it gives off, which could be really important for Earth-based life, or at least life as we know it. HD 20794d sits inside its star's habitable zone, that Goldilocks spot where temperatures are just right for liquid water to potentially exist on a planet's surface. And as we all know, liquid water is a key ingredient for life. The planet itself is what we call a super-Earth. That means it's bigger than Earth, about 6 times the mass of our homeworld, to be exact. Scientists confirmed its existence using over 20 years of data from advanced spectrographs, which picked up the tiny gravitational pull it has on its star. Now, one of the interesting and tricky things about HD 27794d is its orbit. Earth has a pretty round path around the Sun, but HD 27794d's orbit is more of an oval. This means its distance from its star changes a lot, causing it to swing between the inner and outer edges of the habitable zone. This could lead to some wild temperature swings, maybe up to 100 degrees Celsius, between its closest and farthest points from the star. While this makes it tough to say if life could survive on the surface long term, it also makes it a fascinating natural lab for studying how planets handle these changing conditions. The good news is that HD 27994d is relatively close, just under 20 light-years, and its star is bright. This makes it a great target for future telescopes to study its atmosphere. Next-gen telescopes, like the Extremely Large Telescope and the planned Habitable Worlds Observatory, might even be able to sniff out biosignatures, chemical clues of life. While there's still a lot we don't know about what its surface or atmosphere are actually like, being in the habitable zone of a sun-like star and its relative closeness definitely earns HD 20794d a spot on our list of promising future homes. Moving a little closer to home, at number 4, we've got Teegarden's star B. This exoplanet is about 12.5 light-years away and orbits a cool M-type red dwarf star called Teegarden's star. What's really got people talking about this planet is its High Earth Similarity Index, or ESI. For a while, it actually had the highest ESI of any known exoplanet. A 2024 recheck put its ESI at a still very impressive 0.90. This index basically compares a planet's features to Earth's, giving us an idea of how Earth-like it might be. Teegarden's star B orbits nicely within its star's habitable zone, which means there's a better chance that surface temperatures could allow for liquid water. Early guesses put the surface temperature at a comfy 20 to 28 degrees Celsius. That's 68 to 82 Fahrenheit, much like Earth. However, that 2024 study suggested it might be cooler, with an equilibrium temperature around 4 degrees Celsius, 39.2 Fahrenheit. The planet has a minimum mass really close to Earth's, about 1.05 times ours, so it's probably a rocky world. Orbiting a quiet, ultra-cool M-dwarf like Teegarden star has its ups and downs. On the plus side, these smaller, cooler stars live for an incredibly long time, much longer than Sun-like stars. Teegarden's star itself is thought to be about 8 billion years old, nearly twice as old as our Sun. That's plenty of time for life to potentially get started. Plus, quiet M-dwarfs are usually less prone to the massive stellar flares that can blast planets orbiting more active red dwarfs. But even Teegarden's star has shown some pretty big flare activity, which could be a problem for anything living on the surface. One tricky thing about studying Teegarden star B is that, as far as we know, it doesn't pass in front of its star from our viewpoint. This means we can't use the transit method, watching the starlight dim as a planet crosses its star, to check out its atmosphere. So figuring out its atmosphere will depend on future direct imaging tools like the proposed Large Interferometer for Exoplanets, LIFE, or the Habitable Worlds Observatory, HWO. Even with unknowns about its atmosphere and the chance it might be tidally locked, one side always facing its star, Teegarden's star B's high Earth similarity index and its spot in the habitable zone of a fairly close, old star make it a very exciting candidate for future human explorers. Next up, at number 3 is a name that's caused a lot of buzz, Proxima Centauri b. Why all the excitement? Simple. At just over 4.2 light-years away, it's the closest known exoplanet to us. It orbits Proxima Centauri, a red dwarf star that happens to be the nearest star to our Sun and part of the bigger Alpha Centauri triple star system. Proxima Centauri b has a minimum mass of about 1.07 to 1.27 times Earth's, which means it's likely a rocky, terrestrial planet, and, importantly, it orbits within its star's habitable zone. This means temperatures could be right for liquid water if the planet has an atmosphere to protect it. Its year is super short, just over 11 Earth days, because it's so close to its relatively cool parent star. However, Proxima Centauri b has some big hurdles when it comes to habitability. Its star, Proxima Centauri, is a flare star. This means it's prone to really intense bursts of radiation and stellar flares that are way more powerful than anything our Sun throws out. These flares could strip away any atmosphere the planet might have, blast its surface with harmful radiation, and generally make conditions pretty awful for life as we know it. Recent observations with the ALMA telescope have shown just how intense this flare activity is, painting a picture of a harsh space weather environment. Despite these tough challenges, the fact that Proxima Centauri b is so close makes it an irresistible target for study, and, down the road, maybe even robotic missions. Scientists are working hard to figure out if a planet like Proxima b, orbiting a red dwarf, could actually hold on to an atmosphere and what conditions might be like on its surface. Its discovery has even sparked new ideas for interstellar missions, pushing the limits of what we think is possible in space exploration. Understanding Proxima Centauri b isn't just about one planet. It's about understanding if life could exist around red dwarfs, the most common type of star in our galaxy. So, while we're still not sure if it's truly habitable, being our closest exoplanetary neighbor makes it a world we're definitely keeping an eye on. Now let's bring our sights back from those distant exoplanets to our own solar system. Our number 2 contender is a place that's fascinated scientists and sci-fi fans for ages, Jupiter's moon, Europa. This icy moon is thought to be one of the best bets for finding existing life beyond Earth, and for some very good reasons. Europa's real magic lies beneath its frozen surface. There's strong evidence pointing to a huge, saltwater ocean hidden under a thick crust of ice. This ocean, might hold more than twice the amount of water in all of Earth's oceans combined. What keeps this subsurface ocean liquid is tidal heating, the constant stretching and squeezing Europa goes through because of Jupiter's massive gravity and its dance with Jupiter's other moons. This internal energy source is super important because it means the ocean could stay liquid without any direct sunlight. The chances for life on Europa get even better because it's likely this ocean is touching a rocky seafloor. This contact could create hydrothermal vents, like the ones in Earth's deep oceans. On our planet, these vents are packed with life that doesn't need sunlight, surviving instead on chemical energy. These vents could release minerals and chemicals into Europa's water, providing the building blocks and energy needed for life to start and even flourish. Recent observations have even spotted salts like sodium chloride, yep, common table salt, and carbon dioxide on Europa's surface, especially in geologically young areas. This suggests they came from the ocean below and gives us clues about its chemistry. NASA's Europa Clipper mission, which actually launched in October 2024, is currently on its way to this fascinating moon. It's set to do a flyby of Mars in March 2025 for a gravity assist and will reach Jupiter in April 2030. Once it's there, Europa Clipper will make dozens of close flybys of Europa, using its array of instruments to check out the thickness of the ice shell, the depth and saltiness of the ocean, and ultimately whether it could support life. Now Europa's surface gets blasted by intense radiation from Jupiter's magnetosphere. But this radiation might actually create oxidants that, if they make their way into the ocean, could provide a chemical energy source for life. The main challenge for humans would be getting through that thick ice shell and dealing with all that radiation, but the idea of a life-sustaining ocean right here in our solar system makes Europa an incredibly exciting place to explore. And finally, at number 1, the most promising place for human life, at least for the near future, is still our reddish neighbor, Mars. For decades, Mars has been the top pick for human exploration and maybe even colonization, and there are some solid reasons why. It is, by a long shot, the most Earth-like planet in our solar system. Tons of evidence from rovers and orbiters strongly suggests that Mars wasn't always the cold, dry desert we see today. Billions of years ago, it probably had a thicker atmosphere and liquid water on its surface. You can still see features that look like dried-up rivers, lakes, and deltas. Even now, Mars has polar ice caps mostly made of water ice, and there's strong evidence for a lot of ice hidden beneath the surface. Recent studies even hint that a mineral called ferrihydrite, which forms in cool, wet conditions, might be why Mars is red, which points to a wetter past. Mars has some of the key things needed for habitability, like important nutrients in the soil and multiple energy sources, such as sunlight and possibly geothermal energy. Going underground might also offer some protection from the harsh radiation on the surface. However, setting up a human outpost on Mars is going to be tough. The planet has a very thin atmosphere, mostly carbon dioxide, which doesn't offer much protection from solar and cosmic radiation. Surface temperatures are freezing, there's no breathable air, and no liquid water just sitting around on the surface. The lower gravity, about 38% of Earth's, could also cause long-term health problems for humans. Despite these big obstacles, Mars is still the most realistic target for humans to settle beyond Earth in the near future. The idea of in situ resource utilization, ISRU, is a big part of the plan, basically using Martian resources like water ice to produce water, oxygen, and even rocket fuel. Scientists and engineers are actively working on technologies for habitats, radiation shielding, and life support systems. While completely terraforming Mars, turning it into an Earth-like planet, is a massive, very long-term dream, though some studies suggest places like Hellas Planitia could be starting points. Setting up self-sufficient research bases and eventually colonies seems doable in the next few decades. NASA is aiming for crewed missions in the 2030s or early 2040s, with the long-term goal of paving the way for a more permanent human presence. Its relative closeness, the water resources it has, and its geological history make Mars the clear frontrunner for humanity's next big adventure. These 5 worlds are really just the beginning of our search for habitable places beyond Earth. The universe is huge, and we're making new discoveries all the time. Which of these planets or moons do you find the most exciting? Are there any others you think should be on this list? Let us know what you think in the comments below. And if you enjoyed this journey through our potential future homes, please give this video a thumbs up, subscribe for more explorations into space and science, and hit that notification bell so you don't miss our next adventure. From the dusty plains of Mars to the hidden ocean of Europa and out to those fascinating exoplanets orbiting distant suns, the dream of finding another world we could live on is slowly but surely becoming a reality. Now, none of these places are exactly move-in ready, but each one has unique qualities that make them the most promising candidates based on what we know right now. The challenges are enormous, and they'll require some incredible new technologies and a whole lot of human spirit. But what drives this search is one of our deepest instincts: to explore, to understand, and maybe, one day, to spread out beyond Earth, our first home. The coming decades are sure to bring even more amazing discoveries as missions like Europa Clipper send back data and new telescopes look even deeper into space. The journey to find humanity's next address is definitely underway, and the possibilities are as vast as the universe itself.